of a function that what does that be? Sam, what does this function do? What's going on there?
It's like it returns an int.
Yeah.
Has argument c.
Arg C. What do you think arg is short for? Yeah. What do you think C is short for? Yeah. Argument count and arg v. Arg v is an array. Arg v probably stands for something like argument values or argument variables. Well, from what we've seen of, building code, like a thing that you put stuff into and then it gives you something back called a function, argc and argv are arguments, right? This is the format that any function that we define is going to take. So the format is we'll start with the return type, and then the name of the function, and then type of argument 1, type of argument 2, and so on. So every function signature is just going to be like this. Sunny.
We've been learning using pointers to assign values to memory.
Mm-hmm.
Why don't we do that with the integer RC?
This guy? Because int and actually character are these basic types that we talked about briefly last week. So these are values that can be saved directly into memory. When we've been using pointers is when we are creating objects. So these objects are kind of like a wrapper for some basic information that we don't want to ever have to interpret because it would be just a big pain.
So you're saying character is a basic type.
Yes.
Yet that is an array, but where in that does it say that's an array?
So this right here indicates that our basic type is an array of car, which are not quite characters. They're actually saving like basic memory addresses. I really promise you don't have to worry much about it. And then this is the pointer to that place. So where argc is just an int, argv is actually the pointer to an array of car values. It's not an array, it's not a car, it's a pointer.
So you never create a variable in Objective-C for an array using an array and then the name of the constant?
You could if you needed a simple array, so something like an array of the numbers 1 through 5, and then you wanted to loop through them. It would definitely be easier to create something like this. Array is, but in terms of how we do our Objective-C programming, if it's going to be iOS specific, we're probably going to use NS numbers because they give us flexibility. They let us do a whole bunch of functions. Think of this as a static array of those numbers as a shorthand.
I think you might have answered this last time, but why are we saying that the array of the car is a constant, but we don't do that with the other?
Ooh, amazing. Great question. Why is this a constant? And that's because, if you remember, everything that we work with in Objective-C points to a memory address. And so if this wasn't constant, we could actually be changing argv. So This came up probably briefly in DSA, but if not, we will definitely make use of it this Friday. argv is a constant because all of our arguments, if they are references, we can change them. We're used to Swift functions where we can feed in some variable. So I could have Swift functions. Thank you for setting the table so nicely. This is wonderful. Swift functions provide us with values, but Objective-C functions arguments can give us references. So argv is a constant because it's a pointer to where the array of cars is saved, but we don't want anyone to be able to change the value of it. If we know where argv is in memory, we could change that value, and then we would lose track of argv completely. Sunny.
Is it the pointer that's constant, and could the pointer ever change, or is it the values of argv that's constant, or both?
The pointer is constant.
So the values could change, but the pointer is always.
Yeah.
So this whole parameter.
This whole statement is a pointer. Yeah. So argv is a constant because it's a pointer to where the array of cars is saved, but we don't want anyone to be able to change the value of it. We'll often do this if we don't want references or objects to be changed by the encapsulating functionality, encapsulating code in the functionality. Let's say the function. So we'll have to specify, basically, like we see on line 18, hey, this thing argv that you're using inside of this function, you can't change that. Please don't change that. It would make me so sad if we change that. All right, let's make a simple function. I'll put this up here. Let's make a simple function. Let's say we want to make a function that takes in an int and that takes in an int and then counts up from 1 to that int and adds each value to an array and then returns the count of that array. Or what I'm saying is, let's take all this code out of our main function and turn it into a different kind of function. What would the return type of this function be? Thank you, Alex. Let's return an int, because we're returning the count. Nima, what do you want to call our function? Yeah. What's that? Return int. Cool. It gives us blue text. And then what? Stay with me, Nima. You got this. And then what argument or arguments do we need for this function? Think about it in Swift, and then we'll translate it to Objective-C. Say that again. So we don't want to make a loop. We want to make like a function signature here. So just like we would in Swift, where we'd use the keyword func, return int, some arguments, and then dash triangle, the return type. This is just a different order of writing those things. Right now we want the arguments. So what are the arguments for this function? Or argument or arguments? Yeah, so I want to, let's maybe change this. We'll call it take in an int and return an int. Okay, so what would the argument type here be? How would I type this? You can use line 22. So I specify the type of the argument. And then just like with Swift, I need to tell someone how to use that argument. What do you want to call this argument? Yeah, that sounds good. All right. That's it. Now we got to do something in here because it's telling us control reaches end of non-void function. Interesting. What do you think this is similar to? This error, we see it all the time in Swift. If you say have a func return int with the signature int, and then you return the letter A. You definitely get an error there. What's this error probably telling us? Kimball? It's something we're much more familiar with. It's not a closure issue.
Telling it to return it, or not actually returning it.
Yeah. Control reaches, let's see the text of that again. Control reaches end of non-void function. That means we're not returning the right type. Cool. But here's what we can do. We can just set up the name of this function. So we can set up the signature for the function without implementing it. I know, wow. And that's actually very important because for an Objective-C file, Carrie. Yeah. So this is a full function signature. This is just like a function in Swift. What it doesn't have is any implementation inside of like block. I can still do this. This function could just return 1, and that's the declaration and the implementation of it. But I can just, at this point, declare this function without any implementation. I can declare it here, and then set up the implementation elsewhere. And you will see this. And it's important because when this Objective-C file is read, it actually reads in order. So if there isn't something called take in an int and return an int at this point in the code, I can't use it. So I can't say take in an int and return an int if this code is below the place where I tried to use it. It doesn't recognize this function. Where's my error? We get this thing called undefined symbol. So we need to at least declare functions, even if we don't initialize them, before they're going to be used because this file is reading it top to bottom. It's not just taking a big box of everything and letting you read where it goes. We have to declare and potentially implement our functions before they're used. Okay. So this is a pattern you will see often. I'm putting it here just so that it's not scary when you do see it. But we could just return something here. Let's do another logic problem. If we've got an array that is made up of all the numbers between 1 and some n, some count, some int that we give it, and then we take the count of that array, what is the count always going to be equal to? Yeah, so we're making a function. And our function is going to take in an int, and then it's going to, between 1 and that int, add each number, so each integer whole number, to an array, and then take the count of that array. How many things are going to be in that array, Sonny? Yeah. So this function right here, just like we did with the for loop before, can actually just return count. If we're going to add all the numbers between my marker, I'm going to add I is equal to 1, I is less than or equal to count, I plus plus, let's say count is 5. Alex, what's going to be the resultant array?
5.
So just the array.
Sorry.
Let's start somewhere.
1,
Cool.
2,
Keep going.
3, 4, 5.
Then it stops, right? So just take an int and return an int. Instead of iterating, we can just return that count. I think it's fine, Levi. I don't think that face is necessary. So that was fun, right?
Is that what you call an anti-pattern?
Would I call it an anti-pattern? No, I'd call it a fun logic problem. Cool. So here's the thing about this function. Is it an instance method of anything? No, I agree. And Eric M., what's the scope of this function? Yeah, so this function right here, take in an int and return an int, has a certain scope. The scope isn't just on an instance, and I'll tell you, it's also not a class method, what we usually call static in Swift. Oh. Someone trying to watch TV. Come on. Who stole that? What is going on? Hold on just a sec.